In this video, we're going to do a couple of examples and we're going to see whether we're going to need Hopital's rule while trying to find the limits. So the first example is going to be the limit as x approaches -2, and we will have x plus 2 over x squared minus 4. So notice that even though we have an indeterminate form, 0 divided by 0, we can still avoid the Hopital's rule by factoring the bottom. Okay, like this: x plus 2 times x minus 2, right? And then that way you will have x plus 2 cancel, and then you will wind up with simply x minus 1 over x minus 2. Okay, and this can be evaluated, so it's going to be 1 over -2 minus 2, which is equal to -1 over 4. Okay, so you didn't have to use the Hopital's rule. You could theoretically use it and still come up with the right answer because you have an indeterminate form. It wouldn't be wrong, but you can avoid it here in this case. Okay, in the second example, we will have the limit from x is equal to approaches infinity, 3x squared plus 2 over x squared minus 4. So even though this bottom can factor as x plus 2 and x minus 2, the product, the top does not have any similar factors that we can use, right? The most you can do is 3x squared plus 2 over 3, but that's not going to relate to x plus 2 and x minus 2, right? So it's not going to be successful. So if you try to evaluate the limit as it is, it will give you indeterminate form, infinity divided by the infinity, right? And now you have to use the Hopital's rule. There's no way that you can avoid it. So I'm just going to say infinity divided by the infinity, right, in indeterminate form. So now we'll have to use the Hopital's rule and take the derivative of the denominator divided by the derivative, numerator divided by the derivative of the denominator. Okay, and that's going to give us 6x, right, divided by 2x. Right, and the x's can be cancelled, so you will have 3. Okay, so that's your limit value. So in this case, so whenever you have an indeterminate form that you cannot avoid somehow, there's no way that you can avoid an indeterminate form. You must use the Hopital's rule. There's no other way, right? But in all possible cases, you must avoid, you must try to avoid not noticing that the indeterminate form may be altered, okay? Because if it is altered, then it will be wrong to use the Hopital's rule. Okay, so the third example, as x approaches 0, we will have e to the 2x minus 1 over x. So as you can see, we could possibly multiply both the numerator and denominator by the conjugate of the numerator, but that will not do us any good because the x will still exist. So if you try to plug in 0 for the x, you will have 0, and then on the top you will have e to the 2x. That's going to give you e to the 0, that's 1. So you will have indeterminate form 0 over 0. Right? So you have to use the Hopital's rule because you can't avoid it here either. Right? So the derivative of the numerator divided by the derivative of the denominator. Okay, so that's going to give you 2e to the 2x, right, divided by 1, right? So basically you can plug in the 0 now, it will give you 2 over 1, which is equal to 2, right? So in this case you could have avoided. Okay, the next example will be the limit as x approaches 0 of arctangent of x divided by sine of x. So notice that if you try to rewrite it as 1 over sine of x times arctangent of x, okay, so the first fraction, if you plug that in, it would give you 0 over 0, right? So arctangent of 0 is 0, sine of 0 is 0. So indeterminate form 0 over 0. However, if you try to rewrite it like this, okay, making the fraction 1 over sine x times arctangent of x, you would still have an indeterminate form 0 1 over 0 is infinity, right? So you would have an indeterminate form infinity times 0, right, which is an indeterminate form. So you have to again use the Hopital's rule, because there's no way you can avoid it. Okay, so going back to the original, let's and keep in mind that if you would have transformed this into secant of x, right, secant of 0 would give you infinity, right? Because it's the same thing. 1 over sine of x is equal to secant of x. Secant of 0 would give you infinity still, right? So there's no way that you you could have rewritten it. So if we use the derivative, let's take the derivative of the original. So we would have the derivative of arctangent of x with respect to x divided by the derivative of sine x with respect to x. So that would give us the limit value. So as x approaches 0, 1 over 1 plus x squared over cosine of x, right? And now this can be evaluated, right? Because we would have 1 over cosine of 0 is 1, right? So that would give you 1. So as you can see, whenever you cannot avoid having an indeterminate form of any type, you must use the Hopital's rule. Okay, let's try one more example and see what we're gonna get. Okay, so the limit as x approaches pi, sine 2x divided by sine x. So before you venture into checking the Hopital's rule, because you will have an indeterminate form, sine of 2 pi is 0 and sine of pi is 0, right? So you would have to use the Hopital's rule. But before you do that, notice that you can use the identity for this angle here, for the double angle, because the double angle of sine is going to be 2 sine x cosine x, right? Divided by sine x. And that way the sine gets cancelled and you have basically 2 cosine of x remaining, right? And the cosine of pi is going to be -1, so it's going to be 2 times -1, which is -2, right? So in these situations, again, you would not use the Hopital's rule, even though theoretically you could, because there is an indeterminate form. Whenever there is not an indeterminate form, you have to use the Hopital's. You cannot use Hopital's rule. But when there is one, you have to, if you cannot avoid having one. Okay. But in this case, notice that we it's not that we avoided having one, it's just we used the identity that helped us arrive at basically the same thing as what we would have. Okay, because if you use the Hopital's rule, the derivative would be cosine of 2x multiplied by 2, right? So just to check it, the derivative, just for practice, let's see what we're going to have. Sine of 2x divided by sine x. That would give us 2 cosine of 2x, right? The derivative of the outside is cosine, keep the angle the same, and the derivative of the inside is 2. And that would be over cosine of x. Okay, and that could have been evaluated at the pi angle, because cosine of 2 pi is 1, so that would be 2. And then cosine of pi would be -1, right? So that would give you 2 divided by -1, which is -2. So you would have had the same answer. So in this case, if you use the Hopital's rule, you would be correct because you had initially the indeterminate form. And the same in example 1. If you use the Hopital's rule, you still would have gotten the right answer because you had an indeterminate form here, 0 over 0. Okay? But whenever you can avoid it, the Hopital's rule will not be correct. Okay? The Hopital rule use will not be correct. So I'll see you in my next video. We're going to talk about more examples. Please subscribe to my channel, and I'll see you in my next video.